Good morning. This is IOT221. The session is driving operational performance across industrial facilities with AWS. I am Sahil Kumar. With me is Dominic Fortier. He'll be coming on stage later and will be your speakers and guides through the next 1 hour. Let's briefly talk about the focus of the talk today, the agenda. This talk will focus on driving operational performance across industrial facilities with AWS IoT Sitewise and related services. So we're going to talk about a whole suite of different IoT services, with Sitewise being the primary one we're focusing on. We will primarily cover use cases pertaining to industrial, manufacturing, energy, mining, agriculture, and related disciplines. We'll give you a customer example as well. Most industrial companies are figuring out how to get more efficient. That is, they're figuring out how they can produce more output from the same or less input. And whether they do that by automating processes or reducing waste or improving product quality, their end goal is usually the same. That is, more output from the same or less input. Companies want to get more efficient, and Sitewise enables them to do that with less custom engineering, providing a scalable end-to-end solution. We'll talk about why now is the right time to focus on industrial IoT and to invest in this space. Then we'll move into Sitewise, and we'll describe the service in detail and how the service helps customers in the industrial and manufacturing space improve operational performance by identifying inefficiencies in their processes and helping remove them. We'll then move on to a customer example, followed by an end-to-end demo, which Dominic will be doing. The demo will focus primarily on our visual and dashboarding experience, but we will walk through each stage of setting it up with you right here on stage. And then finally, we will wrap up with a summary and information about how to get started. IoT helps transform traditional industrial processes that are manual, inefficient, and error-prone. Most data that is on premises is ultimately thrown away and never analyzed. And inside that data might lie the key into solving those inefficiencies in the traditional industrial processes. The question many customers often ask is, how can I liberate my data that is locked up in on-premise historians, databases, or any other kind of on-premise silo? They want to break free from traditional monolithic proprietary systems, existing IT systems, to get a comprehensive end-to-end view across their global operations, across their facilities, because they want to allow because that allows them to diagnose issues, cross-facility issues, and then take actions to remedy them. Let's begin by exploring some global trends that are motivating industrial operations across the world to raise the bar on operational performance and efficiency. In the last 2 decades, more and more devices are getting connected to the internet, allowing industrial companies to think about the possibilities unleashed by aggregating information across facilities, across their operations, and sharing data between those facilities. There are now ways to even connect legacy brownfield devices to the internet via secondary sensors. So it's no longer limited to the new IoT-enabled devices. You can connect these old legacy devices and also get that data into your data lake. The advent of the cloud has made it possible to aggregate data across facilities that was previously hard to do without a lot of investment in on-premise data centers and hardware, which made it not cost efficient. With increasing global competitiveness, manufacturing operations around the world are under severe cost pressure. And one of the ways to reduce that cost pressure is by investing more in automation via closed-loop systems. By detecting issues early in their processes and automatically taking actions to remedy those issues, companies can invest more in delighting their customers. They can put that savings towards product development, towards innovation. Increasing environmental awareness and climate change targets around the world are also forcing companies to be more conscious about the waste they generate and taking measures to reduce that waste. And lastly, end consumers today have a lot of choice in the market on what they want to buy. And they want to buy from companies that are offering not only good value at the right price, but also manufacturing in an environmentally sustainable way. And so all these factors, when taken together, are motivating companies to improve their operational performance by allowing them to redirect their savings towards innovation and product development. So let's get into it. Here is where IoT Sitewise comes into the picture. AWS IoT Sitewise collects data from the plant floor via a local gateway. It then structures and labels that data and generates real-time KPIs, key process indicators, and metrics to make better data-driven decisions. With Sitewise, you can upload your data into the cloud without writing any custom code, without writing a single line of code. You can browse real-time and historical data to view trends and diagnose cross-facility issues across geographic boundaries. And you can also share dashboards and views with others in your company without hosting a web application and without requiring shop floor engineers to log into the AWS console. We're going to talk a lot more about this during the demo and during the later part of the presentation. It's one of our key new features that allows you to have dashboards and a hosted web application outside of the AWS console, so you don't need shop floor engineers, process engineers, automation engineers, people who are non-developers to log into the AWS management console. It's completely outside of it. So let's talk about OEE. OEE is optimizing equipment effectiveness. And that is the main topic of our presentation today, because that's what Sitewise helps you calculate. OEE is the gold standard for measuring manufacturing productivity. Simply put, it identifies the percentage of manufacturing that is truly productive. An OEE score of 100% means that you're manufacturing only good parts as fast as possible with no stop time. In the language of OEE, that means 100% quality, that's only good parts, 100% performance, that means as fast as possible, and 100% availability, which means no stop time. So if I had to describe Sitewise to you in one sentence, I would say Sitewise helps you calculate key performance indicators such as OEE to help you better optimize your industrial systems and processes in a scalable and cost-efficient way. Measuring OEE is a manufacturing best practice. By measuring OEE, and more importantly, by measuring the underlying losses, you will gain important insights into how to systematically improve your manufacturing processes. OEE is the single best metric for identifying losses, benchmarking processes, and improving productivity of manufacturing equipment by eliminating waste. Let's walk through an example. So OEE can be calculated by multiplying availability, performance, and quality. Availability is defined as the difference between potential production time and actual production time. Performance is the difference between theoretical output and actual output. And then quality is the difference between actual output and actual good sellable product. So in the example you see on the screen, if OEE was 100%, we would produce 4,800 pieces of good sellable product. But as you're going to see, we only produce 2,736 pieces of good sellable product because there are losses at various stages. So you have a potential production time of 480 minutes, but an actual production time of only 360 minutes. You're losing 120 minutes due to availability losses, breakdowns, changeovers, line restraints. Then, of the 360 minutes of actual production time, you can theoretically produce 10 pieces per minute, so 3,600 pieces. But the actual output is only 2,880 pieces, and that's because performance losses, minor stoppages, reduce speed. And then off the actual output of 2,880 pieces, you only have good sellable product of 2,736 pieces. So you'll lose some again due to quality losses, scrap, rework. And individually, while these are all small, when taken together on the bottom right, you see the multiplier effect is there's a huge effectiveness loss. So in this example, your OEE is a mere 57%, which is pretty low. Right? And so companies, if you are operating with an OEE like that, would definitely want to reduce that loss, and Sitewise helps them do that. Now, there are some pitfalls with OEE too, and I would like to highlight two of those pitfalls, common pitfalls with OEE. One is over-indexing and over-focusing on the OEE score, not the underlying losses. OEE measures how close you are to perfect production. The true value of OEE comes from understanding the underlying losses. By focusing on the losses, and more importantly, by taking actions to reduce those losses, your score will naturally improve. So don't over-focus on the score. And second, using OEE to compare dissimilar processes. So Sitewise will allow you to calculate OEE across global facilities and compare it, which can be useful, but it's only useful when comparing the same equipment, running the same product under the same condition. For example, it's not meaningful to compare OEE for a production line that has 12 changeovers per day with OEE for a production line that has 2 changeovers per day. That would be an apples to oranges comparison. So resist putting too much weight in comparisons of dissimilar processes. And while such comparisons can provide some meaningful insights, they can also provide as much misinformation as much good information. So next, let's walk through a customer example. So this is a real customer which actually used Sitewise in production already. And the customer is Bayer Crop Sciences. Bayer Crop Sciences is a division of Bayer whose purpose is to propel farming's future with cutting-edge agricultural and environmental innovation. Bayer was looking for a digital factory solution that can help it manage multiple crop sites, each comprising of 5 to 6 different processes. They were looking for several capabilities. They were looking for performance optimization and monitoring, end-to-end operational visibility, logistics and supply chain optimization, digital twins via simulation models, quick insights and dashboards, and reporting. One of the main motivations behind this was that 18% of perfectly acceptable agricultural produce in the US is lost in processing. And Bayer's goal was to eliminate that waste. Bayer used Sitewise in production in the 2019 US harvest season across 9 of its sites, and it plans to expand to additional sites worldwide. End-to-end visibility was a top priority for Bayer. They wanted dashboards that display machine data and metrics derived from each asset and process. So what is a process for Bayer Crop Sciences? It's like a bagger, a sheller, a husker, because this is agriculture. So these metrics can help operators identifying underperforming processes and then take actions to remediate the situation. The machine data can help isolate equipment or configuration issues that are causing those processes to underperform. And Bayer wanted these dashboards to be accessible anywhere, by anyone, from any device. And so they built a custom dashboard. You see that on the screen. In the red, you see they calculated their OEE. And the reason they built these custom dashboards using our underlying APIs is because back then we did not have the Sitewise monitor capability, which we'll talk about next, which is the inbuilt dashboarding capability. So today we have the ability for customers to build their own dashboards like Bayer did, and you can see a snapshot on the screen, or use the inbuilt dashboarding capability that comes out of the box with Sitewise. All right, now we're going to talk about the steps to unlock value from IoT equipment. Before we get into that, I'm going to talk about the industrial IoT maturity model. So what is the industrial IoT maturity model? On the screen, you see 6 stages of the industrial IoT maturity model. Industry 4.0 is the trend towards automation and data exchange in manufacturing technologies and processes, which includes cyber-physical systems, industrial Internet of Things, AI, and other related fields. In the 80s and 90s, we saw the era of computerization. And I won't spend much time on that because most of us are already pretty familiar with it. In the late 90s and 2000s, with the advent of the internet, we saw the era of connectivity. In the 2000s, also claimed cloud computing, where now instead of buying, owning, and maintaining your own data centers and hardware and servers, organizations could acquire capacity like compute, storage, databases, and other services on an as-needed basis. They were now only going to pay for what they were using, and capacity could grow and shrink instantly. The cloud offers agility, it offers cost savings and a breadth of functionality, allowing customers to globally deploy in minutes. If you look at the maturity model, connectivity is one of the key foundations for Industry 4.0. And AWS IoT Core is a managed service that helps you securely and easily connect your devices to cloud applications and have interactions between different devices. IoT Core can support billions of devices and trillions of messages and can process and route those messages to AWS endpoints or to other devices securely and reliably. As we move into the right-hand side of this industrial IoT maturity model, you move from connectivity to visibility, from visibility to transparency and to predictive capacity. And finally, you go to adaptability. So it is going from just seeing what is happening to understanding and being prepared for it. Just getting the data from equipment and visualizing is no longer enough. You want to gain insights from that data that'll help you make your processes and your systems more efficient. And once you get there, you can think about taking the final leap into self-optimizing closed-loop systems, which is the North Star for Industry 4.0. most industrial companies are still in the connectivity and visibility stages. And even then, their visibility is rarely cross-facility. IoT Sitewise will enable your industrial operations to embark on this journey, no matter where you are on this maturity model. So, the 5 steps to unlock value from IoT equipment. There are 5 steps, and those are data collection, information modeling, calculating performance metrics, visualization, and detecting and responding to events. And we will take you through each of these in the context of Sitewise next. So, data collection. One of the most important things for customers, and the first thing they need to handle in their IoT journey, is how to get their data, which is locked up inside industrial facilities, inside proprietary databases on the factory floor, how to get that data into the cloud and easily accessible. And this is where the IoT Sitewise gateway comes into place. The gateway is essentially software that runs on top of an AWS Greengrass core. The gateway securely connects to your on-premise data servers. It collects the data and sends the data to the AWS cloud. You can run your gateway software on an AWS Snowball Edge. You can install it on any popular third-party industrial hardware. In fact, you can run it on any server that supports Linux. You can also simply just set up a virtual gateway in EC2 to test things out, so you don't have to buy real hardware to do this. The gateway caches data locally in case of intermittent internet connections, which are very common in remote facilities. The gateway allows multiple aggregators to be connected to a single industrial gateway, up to 100 to 1. Customers in the future will optionally be able to add DIY functionality to transform or filter data at the edge before uploading it to the cloud. Additionally, with IoT Sitewise Gateway comes management and insight capabilities that will help you operate and maintain and monitor your gateway's health over time. While the gateway today only supports OPC UA natively, we will add support for many additional protocols over time, along with the capability to add support for custom proprietary protocols. So that set of protocols that we will support will expand. So here's a look inside a gateway, actually on a factory floor. So on the left, it's in a rack. So on the left, you see both the PLC and gateway. They're plugged into a network switch. And on the right, you see a server that's hosting the IoT Sitewise Gateway software package. You could also have the OPC UA server run on the same machine if it's a powerful machine. So the idea of showing you this is to show you how very compactly this can be set up on your factory floor. So, IoT Sitewise Gateway supports vendor-neutral OPC UA protocol. It supports the most common OPC UA identity providers, including certificate-based identity. We consume time series data using the OPC UA subscription model, and IoT Sitewise Gateway automatically handles connection drops and timeouts. Sitewise enables end-to-end secure connectivity using certificate-based authentication. The OPC UA server credentials for your OPC UA server from where we are pulling data from are stored securely in AWS Secrets Manager and deployed to the AWS Greengrass core. With Sitewise, you have the ability to manage and configure gateways remotely via the AWS console. So you don't have to have someone on every factory floor be able to manage these gateways. You can do it all remotely. And lastly, minimum firewall changes are needed to add a gateway. It can be configured such that all communication happens over port 443, which is important for many companies because they have strict IT guidelines on what ports can be opened in their factory networks. There's also a second ingestion path into Sitewise. So what if your data is not already aggregated on an OPC UA server or a historian? What if you just want to ingest device data directly into Sitewise? Well, you can do that with our integration with IoT Core. Customers can route device data, messages ingested into IoT Core using Rules Engine with Sitewise as a target destination. So you can direct device data directly into Sitewise. And once the data is in Sitewise, customers can create virtual representations of that data, of their assets, of their processes. They can calculate KPIs, and then they can visualize their data. The third step with Sitewise is creating information models. Sitewise allows you to create information models of your industrial systems and processes and associate those models with data streams. Data without context is meaningless in the IoT world. It's just data, it's just bits and pieces. To make that data into information, you can contextualize that data and add context to it with an information model. And in this example on the screen, you see a very simple information model which we created. It's just a wind farm which has many wind turbines, and then a wind turbine has properties such as wind speed, wind direction, torque, velocity. And we'll walk through another example later. These measurements collected from various assets are uploaded to our cloud database via the gateway which we just talked about. And both these measurements and the metrics that are calculated from these measurements, which we'll talk about in the next section, are accessible via our APIs. So they can be consumed by custom downstream applications. Each asset can have multiple measurements and metrics associated with it. And we allow customers to create complex hierarchies of assets to represent their real-world scenarios. With Sitewise, we expect customers to be able to have hundreds of thousands of assets across a variety of different asset models. With Sitewise, while all the functionality and information modeling and all this capability is available via our very rich AWS management console for scale, it can also all be scripted and used via our APIs. Okay, next we'll take you through an example of modeling a solar farm using Sitewise. So Sitewise can be used to model solar farm and track power output at various levels, at a per site level, a per geolocation level. And so we'll just walk through a simple example of modeling a solar farm. The first thing you have to do in Sitewise when you want to model something is define an asset model. And an asset model is something like a template for an asset or a process or a system. And while a solar farm will have many different types of equipment that we might want to model, for this example, let's just model a power meter because it's simple and it's easy to understand. So a power meter will have something like a name. It'll have an attribute like nominal power. This could be a fixed value, for example. It could have metrics. So the metrics here are real power and efficiency. And those metrics are a function of a measurement. And that measurement is a power meter reading. So there's a reading from a power meter, and the reading of that power meter is the measurement, and a function of that measurement is the metric that we calculate. So how does it all work? Once you define that asset model, using that asset model, the template, you can stamp out, you can instantiate several assets. You can instantiate hundreds of thousands of these power meters using that model. So here you have an asset model, and you can create different assets from that asset model. How do you know these are unique assets? It's not just a name that is unique. So they all have different names. There's CA1751-1A-1B-1C. But they're all also connected to a unique power meter from where they're getting their measurement. So it's not just the name that's unique. They're actually connected to a separate physical device, each of them. Now, once you define these power meters, you could create a hierarchy of power meters. So you could have multiple power meters in a solar array. You could have multiple solar arrays in a solar farm. And you could have multiple solar farms in a state like California. So you create a complex hierarchy, and this is a pretty simple hierarchy. You could create a very complex hierarchy of your assets. And then you can calculate metrics at each level of this hierarchy. So you could calculate the real power metric at a solar array level, at a solar farm level, or for all solar farms in the state of California. So this is via a functionality and a feature we call roll-up metrics. So you can roll up these metrics at each level of the hierarchy that you define. All right, the fourth step of Sitewise is calculating performance metrics. So once you have all your data from industrial equipment flowing into the cloud, and it's contextualized with an information model, you're ready to start calculating performance metrics. Metrics can be calculated by building formulas, statistical formulas, mathematical formulas, and then by performing functions over the measurements. We can calculate things such as OEE, production time, downtime, defect density, capacity utilization, throughput. These are all examples of metrics you can calculate. It can frankly be anything you can define a formula for. Sitewise has raw measurements from equipment pre-computed aggregates such as sum, count, average, min, max, which you can use in dashboarding applications, and custom metrics, which are defined by the customer. It's the formula you define. Sitewise allows you to define and calculate custom metrics such as OEE by defining formulas for those metrics. And metrics can be mathematical or statistical today. But in the fullness of time and in future, they will also be tied to ML models, such as a random cut forest model for anomaly detection, or a predictive maintenance model. These custom metrics, similar to raw measurements or similar to the pre-computed aggregates we just talked about, can be accessed via APIs to consume in custom downstream applications or dashboards, avoiding the hassle to query individual data streams and aggregate them on the fly. Using our pub/sub interface, with the click of a button, customers can enable notifications on specific asset properties and consume those notifications in downstream applications as those properties get updated. So that is yet another feature to build other stuff on top of Sitewise using that pub/sub interface. Now let's walk through a real example of calculating OEE. So here we have an asset, it's an asset called Packer. And this Packer has three measurements. It has equipment state, it has good count, and it has bad count. Equipment state in this case is a numerical code. So to interpret that numerical code, we create what we call transform measurements. So you have a transform measurement like idle when the equipment state is 1024, or stopped when the equipment state is 1000, and so on and so forth. So we're transforming the measurement into some meaning. We're interpreting that code. Now, we can calculate metrics. So we can calculate idle time, which is the amount of time the asset spent in the Packer state, or fault time, which is the amount of time the Packer spent in the fault state, and so on and so forth. And then you can calculate things like downtime, which is a sum of stop time, fault time, and idle time. And finally, you can calculate availability, performance, quality, and then multiply them all to calculate OEE. So you can calculate metrics, those metrics can be used in other metrics, and so on and so forth, till you get your higher level metric, such as OEE. Lastly, visualization. Well, actually, there's one more, so this is number 4. So visualization, once you've got all this stuff done, you've got your data flowing into the cloud, you've contextualized it, you've calculated performance metrics, you're ready to start building dashboards. And the way you build dashboards with our inbuilt dashboarding capability called Sitewise Monitor is simply by dragging and dropping the appropriate widgets you need on a canvas. Domain experts, such as process engineers, can then use these dashboards to quickly get an insight into their operational data, to understand equipment behavior, and they can use these insights to improve efficiency of their devices or equipment. Customers can browse raw data coming from equipment, production lines, and processes. They can view their respective performance metrics very, very quickly and easily. They can also view and compare historical data from different equipment over time. So you can view real-time data and you can view historical data both. And this is without writing any code. This is completely out of the box. IT admins can set up applications containing these dashboards without provisioning the application stack. That is, they don't have to provision the compute and networking resources required to host an end application, and they don't have to write any code. Every application is fully set up and managed by AWS, and there is no infrastructure to launch and maintain. So these dashboards are a hosted web application, and customers can provide access to their enterprise LDAP users, and they can view and share their dashboards with their enterprise users. So you don't have to create AWS logins for these shop floor engineers. You can just easily connect to your existing enterprise Active Directory systems, so IT admins can securely meet the requirements that they're familiar with for the familiar access and authorization models that they have in their enterprise. These applications can be accessed from a browser or any desktop, tablet, or phone, and making it simple and flexible to use for end users. The unique thing about this offering is that it's completely outside the AWS console. So day-to-day users need no knowledge of AWS. They don't even need to know it's hosted on AWS. They simply go use an enterprise application, a dashboard, using a URL that they have access to. This is a screenshot. You're going to see a lot more of this in the demo, but this is a screenshot of how we have real-time interactive, customizable dashboards with site-wise monitor. And it's an awesome feature, and we're going to hear more about it in the demo. So the last point here now, once all your data is collected from the factory floor into the cloud, you've modeled it, you've created metrics. You want to use those metrics and those measurements to detect and react to events. And here's where another IoT service called IoT Events comes into place. IoT Events allows customers to continuously monitor data from equipment for changes in operation and trigger the appropriate response when events occur. So operational events can vary from multiple things. They could be an equipment malfunction, like a stuck door, or a refrigerator not opening in a manufacturing facility. Or it could be sign of wear and tear on equipment requiring preemptive maintenance, or a part change that needs to happen, like replacing a dirty filter or changing a battery. So detecting these things and then responding to them automatically is something that is possible with IoT events. Metrics from SiteWise can be routed to IoT events as inputs. And with IoT events, customers can build very simple or very complex detector models to monitor state and detect events. Each state has an entry and exit condition, and equipment or processes transition between states, and as they transition between states, you can associate those transitions with events. Actions supported by IoT events include any custom action via Lambda, or initiating an alert in an AWS service like SNS or SQS. We support an action library that has many of the same actions as the IoT rules engine. IoT Events is a stateful service. It is both idempotent and strictly consistent. And by integrating SiteWise with IoT Events, you can build closed-loop applications that take actions based on data, based on measurements, and based on calculated metrics. So next, we are going to walk through a demo of everything we just heard about. My colleague Dominic will walk through that, and he'll show you how you can use SiteWise to calculate metrics such as OEE, and then visualize those measurements and metrics.
Thank you, Sahil. Let me switch to the demo quickly. There we are. So, my colleagues, Sahil, talked about creating models, creating hierarchies, creating assets to represent an industrial operation. So let me show you with a concrete example how this would be done. So let's imagine for a second that I have a factory that is composed of multiple different lines, assembly lines, and each assembly line has multiple different conveyor belts, and each conveyor belt fills multiple different stations. How would I go about modeling that inside SiteWise? Well, as the industrial engineer whose job is to do that modeling, I would go inside the SiteWise console, and I would start create models. So let's create ourselves, let's say, a station. So I would say we're creating a station model. I could say, for example, what is the nominal part rate for this station? I am expecting this station to produce 50 parts per minute, let's say. I would also attach the different measurements coming from the OPC UA servers, coming from routed by the gateway to the service. Such measurement could be good part count, for example. And another measurement could be the equipment state. So the equipment is telling us its state as an integer. Then this equipment state might be a code. It might be like 900 means running and 700 means at fault. So this isn't really useful. So I probably would want to transform that and say something like running is if the equipment state is equal to 900, we'll consider that running, for example. And then I could also define metrics. Like, for example, I could say that my total parts per minute would be the sum of the good part every minute. So let's create this model right now. And let's create a conveyor belt, because conveyor belts is what's feeding these different stations. So we'll just create quickly a conveyor belt here. And we'll just stop at that and say this is a conveyor belt. And we're going to say, but conveyor belts have a hierarchy of stations underneath them. So now what I've just said is we know what a station is, we know what a conveyor belt is, and we also know that the conveyor belt can contain multiple stations. So while this is happening, now that we know what the different things are and what they contain and how they work, let's go create ourselves a few actual instances of these stations. So let's create a station. Let's call it Station 1. Let's create another one. Station 2. Now that we have two stations, now in reality in my factory I would have more than that, but now that we have two stations, we probably want to say to our system, you know these measurements that are coming from the actual equipment, how do they map to the OPC UA server tag? This is the typical way in an industrial operation where these OPC UA servers have something called tags, which identify unique measurements. And we're going to say how this maps to these models and these assets that we created. So depending on the convention used in that operation, it might be, let's say, the Renton site underscore line 1 underscore conveyor 2 or 1 underscore station 1, for example. And you would do that, this mapping between the OPC UA tags and the different measurement for every OPC UA tag that you need to map to the model. Now that this is done, let's also create ourselves one of those conveyor. So we're going to call it conveyor 1. Great. So now we have a conveyor belt, and we also have two stations. And we've mapped some of the measurements from those stations to the proper nodes inside the model. So the final stage of this entire thing here, I'm going to verify, like, OK, my station is active. It's been created. We're good. The conveyor belt is actually active now. The last and final stage is I probably want to say to the system, Station 1 is actually part of conveyor 1. And Station 2 is also part of that same conveyor. And there we go. Now what we have, if we look over here on the left pane, now what we have is a hierarchy. Now this hierarchy right now is fairly simple. It's only 2 levels deep. You can get way more complex and involved hierarchies. Now, for the purpose of this demo, I'm going to switch now and show you a much more fully baked hierarchy of that similar example. So I'm just going to switch to a different region right now where I have this hierarchy created. And you see there's my site. My site contains an assembly line. My assembly line contains multiple different conveyor belts. and each conveyor belt contains multiple different stations. Well, let's look at one of these stations, just randomly one. And here we have station A2. Station A2 has an attribute that's the identifier, has a number of different measurements coming in, the good count, the bad count, the equipment state. We're using multiple different transformations to calculate, is it at fault, is it idle, stopped, or running? And then, finally, we're calculating a number of metrics from that base station. We're calculating the count of the current good count in the parts in the minute. We're calculating the fault time, the stop time, the run time, the downtime, the idle time. We're calculating, coming from those base metrics, we're calculating the availability, we're calculating the performance, we're calculating the quality, and all of that to end up calculating that OEE metric that my colleague talked about. And here in the console, while I'm building all of that as the industrial engineer, I can take a peek and see what are the latest values that are coming in. Do they actually seem to make sense? So now that this station has all of that, we also can look at the conveyor, for example, and we are rolling up the metrics from all of its underlying stations to say the average OEE of that conveyor is the average of all of the underlying stations OEE. So you can see that you can roll up metrics like that across a hierarchy. Great. So now this is an industrial engineer that's setting up all of those metrics, those KPIs, that's setting up all of that. But the factory floor manager wants access to all of that, and he doesn't have an AWS ID, he doesn't log to the AWS console. So what I'm doing as an industrial engineer is I'll partner with my IT department, and I'll create a portal. I'll use the monitoring functions of SiteWise to create a portal associated with that identity, that LDAP identity, such as Active Directory, and create an actual user dashboard or multiple different dashboards that my factory floor manager can use. So I'm going to show you that now. I've worked with the IT person, and I've created this portal that my factory manager can log in using his normal enterprise credential and view what's happening in the factory. I've created ahead of time for him a number of different dashboards that he can use to inspect the performance of the factory. So let's log into this portal. So this is currently logging in using his identity, his enterprise identity. And now you can see the dashboards and the projects that I've created for him. So let's take a look right now at those dashboards, and let's imagine the following case. Imagine I'm looking at that and I'm saying, I don't know why, but my assembly line, my factory, my assembly line number 1, is seeming that like the OEE coming out of it right now is really bad. The performance of it is really bad, and I want to understand why. So I'm going to use those dashboards that have been created for me to investigate what's going on. So first of all, I'll open the assembly line that seems to be in trouble, and well, 10 minutes is probably not enough. Let's see what's been happening there over the last day. So over the last day, I see, yeah, the OEE of that assembly line has been hovering somewhere between 85 to 90%. I mean, it's not too bad, but this is way below what I would like to see. So now, I know that there's multiple different conveyor belts. And I look at these conveyor belts and I say, wow, my conveyor B and my conveyor C are pretty much right on the spot for as far as what the OEE is. They're pretty close to 100%. They're performing really well, consistently over the last day. But my conveyor A seems to be having serious problem. So I'm going to dig in a little deeper than that. I'm going to say, OK, great. So it seems like we've identified that conveyor A is having issues. Now, my engineer has already created other dashboards for me, including a dashboard to see what's going on with conveyor A. So let's switch as well the time here to see that what is conveyor A been doing. And if I look at it, I see that conveyor A as an availability and a performance that was really around 70%. Now, on the quality, we are somewhere between 92 to 94%. So while we are producing parts, they're pretty good. We're not having a lot of rejected parts. But really, I can tell that the availability and the performance seems to be what's the problem. And just taking a quick peek at the different stations connected to that conveyor belt, I can see that station 2 and station 3 are behaving perfectly well, but station 1 is the one that's truly having an issue. So now looking at that, what we're going to do is we're going to dig in one more level, and we're going to go into station 1 and see what's going on with station 1. So let's see. So for station 1, what is going on is the performance of station 1 has been really, really bad. The availability as well. The quality, again, is good, but we're having issues. And we're having issues because it's been down a lot. We see right there that the downtime of station 1 is around 50 to 55. So this is actually the root cause of why my entire factory productivity has been impacted. And now that I've seen that, I can dig into that. Now, my colleague earlier talked about these pre-computed aggregates too. Because of these pre-computed aggregates, that allows me to go very, very quickly from looking at a day, a week, a year worth of data, and really, really drilling in to, for example, what's been happening in a very specific time frame, and be able to say, like, this minute specifically is where we experienced a downtime or something like that, and go back and forth and dynamically go from minute level granularity back out to day, weeks, year granularity. So with that, this concludes my demo. So let's switch back to the rest of the presentation. So in summary, if I recap overall, AWS IoT Sitewise is a product that lets you go all of the stages from collecting the data from your factory floor, structuring, giving meaning to that data, moving it from being data to being meaningful information, generate near real time the KPIs and metric to make a better data-driven decision. Then, once you have that, you can actually create entire workflows coming from that, as well as visualizing and drilling in and understanding where problems are and how you can optimize your factory operation. Recapping the 5 steps of unlocking the value from data collection, information modeling, performance metrics, operational dashboard, and finally detecting and responding to complex events. Sitewise and the family of IoT services and other AWS services let you realize that full value together. So how do you get started with Sitewise? Well, we are currently in preview. There is no whitelisting required. Anybody can go and try this service. We're currently in preview in 3 regions. We are in US East 1, US West 2, as well as EU Central 1. Normal terms of usage apply for a preview service. There is currently no billing, no cost to using the service during the preview period. And really, go give it a try. Give us feedback. We want the feedback. We want to be able to build what you guys need. So this is a great time to try it. Give us the feedback so we can incorporate it into the product. Now that you got your learning started, it doesn't stop here. We have a lot of training and certification for IoT and all of AWS. There's multiple different additional free digital courses available to you, certification. Bring your colleagues and learn more from here. Let's not stop today at this presentation. Finally, we want to thank you, my colleague and I, Sahil and I. We want to thank you for being here today. And before you leave the conference, please take some time to complete the session survey in the mobile app. Thank you.